All right, remember that the first law of thermodynamics says that energy cannot be created or destroyed. It's the law of conservation of energy. So we can transfer forms of energy between light or motion or potential energy or energy stored in bonds or heat, but we cannot create or destroy. It's always just changing forms. And the second law of thermodynamics says that energy can change forms, but every time there will be some heat that's released. The ultimate fate of all energy is to be released as heat, and when we release this heat, we increase the entropy or disorder of the universe. So we're always making the universe more disordered. And living cells, because we're doing these processes that release energy to our cells, like we're breaking down glucose, we're making a lot of heat. That's where all the heat inside of our body comes from. That's why we are 98.6 degrees all the time, because of the heat that's released from our metabolism as we're changing forms of energy. And so spontaneous processes are ones that can happen without us putting in energy. So for example, we do not put in energy to break down glucose. So glucose will ultimately, it will break down into oxygen over time, or into water and carbon dioxide, I'm sorry. It will ultimately do that. It will be spontaneous. However, it doesn't mean that it's going to happen fast. Without enzymes, glucose breaking down into carbon dioxide and water would take forever, infinite amount of time. But it would happen on its own eventually. We don't have to put in energy for it to happen. And for it to happen without energy input, it must increase the entropy of the universe. And that makes sense because we have this ordered molecule, 6 carbons, 12 oxygens, or 12 hydrogens and 6 oxygens. And we're breaking it down into 6 carbon dioxides and 6 waters. And so we're increasing the entropy of the universe. We had 1 molecule, now we have 12. So it's way less ordered. So we are increasing the entropy or disorder of the universe. So something important about life is that cells create ordered structures from less ordered materials. So when we are making molecules and such, when we're building proteins or building lipids or building carbohydrates or nucleic acids, or plants are taking carbon dioxide and water and turning it into glucose, all of these things are cells ordering materials, right? We're taking 20 amino acids and turning it into 1 protein. We just went from 20 molecules to 1 molecule. It's way more ordered, right? So that's cells creating order from disorder. So we create more ordered molecules from less ordered molecules, but we take ordered forms of matter and energy and change them into less ordered forms. So it's always going back and forth. So energy flows into an ecosystem in the form of light. So all energy for living things comes from the sun, basically. Sun goes into plants, plants make glucose, they give glucose to other forms of living things, and then we use it in our metabolism and release it as heat. So if you're working out, you're using your metabolism way more than you normally would because your cells need more energy because you're requiring more of them, and that's why there's more heat, because your body's working faster and more heat is being released during the chemical reactions. So these pictures are just your textbook showing that life creates order. So these are ordered molecules made from disordered universe. And so even though we're creating ordered molecules from the disordered universe, we are not violating the second law of thermodynamics, which says that the entropy of the universe is always increasing. Rather, we can decrease the entropy of ourselves, of an organism, but the universe's total entropy is increasing as we do that. Because in order to make those complex ordered molecules, we are using energy, which is being released as heat. So the heat is increasing the entropy of the universe.